we will be discussing the problems on PERT method, that is Program Evaluation Review Technique method. Get that? So this is second type of problems we are seeing in network analysis now. So here the question is given in this case. Construct the network diagram for the project whose activities and 3 time estimates are given for the given below. 3 times, what 3 times here means? T0, Tm, Tp. T0 is optimistic least time, Tm is mostly like time, Tp is pessimistic least time, pessimistic estimate time. Here T0, Tm, Tp are given for each activity 1 to 2, 2 to 3, 2 to 4, 3 to 5, similarly for until 10, 9 to 10. Now what we are going to do here means we are going to find using T0, Tm, Tp, Te. T is called estimated time to complete the activity in the project. So after finding Te, after you find Te and using activities 1 to 2, 2 to 3, and we start drawing a network diagram. After drawing a network diagram, we are finding a critical path. Get that? After finding critical path, we are calculating the how expected variance. We are finding expected variance for the project. Before that, 3 conditions has been given in this question. That is, the first one is called expected duration of each activity. Expected duration of each activity is called Te. My Te can found by using T0, Tm, Tp in the formula Te equal to T0 plus 4Tm plus Tp divided by 6. Get that? And expected variance of each activity. Expected variance square equal to Tp minus To divided by 6 whole square. Is it clear? By using this formula, we are going to find sigma T square. So this is the required table for us. What the table contains here? Activity T0, To, Tm, Tp. Estimated expected duration formula is T equal to T0 To plus 4 Tm plus 4 plus Tp divided by 6. I repeat again, Te equal to To plus 4 Tm plus Tp divided by 6. Expected variance for each activity 1 to 2 like that. Sigma square equal to Tp minus To divided by 6 whole square. Together. Now, what you need to do? You need to calculate Te for each and every. These activities and To, Tm, Tp already given in the question. Same thing I have written back. Together. So, let me take it for 1 to 2 activity. My Te equal to, let me show the calculations here. Te equal to To. What is the To? 3 plus 4 Tm. 4 Tm is 4 into 4 plus Tp is plus 5 divided by 6. Now calculate it. 3 plus 16 plus 5 divided by 6. This becomes 18 plus 5. This becomes 19 plus 5. 24 divided by 6 equal to 4. This is Te. So my Te equal to 4. 4 ಮಾಡ್ತಾರೆ.
ಕಟ್ ಮಾಡಲೇ.
Now activity 2 to 3. For activity 2 to 3, Te equal to To plus 4Tm plus 4 plus Tp divided by 6, right? So similarly 1 plus 4 into Tm, that is 2 plus 3 divided by 6. This becomes 1 plus 8 plus 3, that becomes 12 divided by 6 equal to 2. So I will be getting as 2. Now similarly I proceed for each and every activity by using the Te formula. When you use the Te formula for each and every activity here, I will be getting as Te values 3, 4. For activity 4 to 5, I will be getting as 3. For activity 4 to 6, I will be getting as 5. For activity 5 to 7, I will be getting as 5. For 6 and 7 I will be getting as 7. I will be getting as 7. For 7 and 8 I am getting as 4. For activity 7 to 9 I will be getting as 2. For 8 to 10 I am getting as 6. 9 to 10 I am getting as 5. So these are my expected durations. These expected durations only I am taking for drawing network. Is it clear? Now sigma square, expected variations for each and every activity. What is that we have to do? Again we have a formula here. Sigma square equal to TP minus TO divided by 6 whole square. Sigma square equal to TP minus TO divided by 6 whole square. For each and every activity again you are finding that. For activity 1 to 2, let me consider TP minus TO. What is TP here? 5 minus TO 3 divided by 6. This will become for activity 1 and 2, for activity 1 to 2, TP is 5 minus TO is 3 divided by 6 whole square. That's called sigma square we have here. Sigma square equal to 2 by 6 whole square. This becomes 1 by 3 whole square. This becomes 1 by 9. So what is our sigma square for first activity? 1 by 9. Together. Now for second activity 2 to 3, sigma square equal to TP. What is the TP value here? 3. 3 minus TO value is 1 divided by 6 whole square. This becomes 2 by 6 whole square. That becomes 1 by 3 whole square. That is equal to 1 by 9. Together I replace as 1 by. Keep it as a fractions. No issues for us. And next activity 3. Similarly, when I go for activity 3, 4 minus 2 divided by 6 whole square. That means 2 by 6 whole square, again 1 by 3 whole square, that becomes 1 by 9. Similarly, I proceed for calculating for each and every activity by using this formula. Repeatedly for each and every activity again and again. So what I will be getting answers here. For third activity also I will be getting 1 by 9. For fourth activity also 1 by 9. For activity 4 to 5 I will be getting as 4 by 9. For activity 4 to 6 I am getting as 4 by 9. Activity 6 to 7, 1 by 9. For activity 7 to 8, 4 by 9. For activity 7 to 9, 1 by 9. For activity 8 to 10, 4 by 9. For activity 9 to 10, 4 by 9. All these sigma squares I got using the formula sigma square equal to TP minus TO divided by 6 whole square for each and every activities. This is two terms we have found it. What is the first term? Expected duration. Found. Expected variance, you done it. Now the next intention is expected variance for the project, entire project. That can be found after finding the critical path. When you add variances of critical activities, sum of expected variances of critical activities will give you the expected variance of the complete project for us. So let us find critical path. Further, let us draw a network by using the activity and TE. I am taking activities and TE. My TE is the time duration to complete activity 1 to 2. So using activities with the time expected durations TE, I will be drawing a network now. Okay guys, now let us start drawing a network by using activities. 1 to 2 activity, first activity what I am starting here. So my initial node is 1. Initial event is 1. Is it clear? So last event is 10. So I need 10 events on the network. You get that? Let me start simultaneously and marking the next active events. I will start drawing the networks, start drawing the activities simultaneously to complete all the events here. The first one is 1 to 2. 1 to 2. I will be drawing. So 1 to 2, the time, which time I need to mention here? Expected time. You get that? Expected duration T, what I found here, this T values I should mention for the time duration in the project. You get that? For each and every activity. That becomes 4. T, this is T values. All the network should contain T values here. And next one, 2 to 3. I will mention 2 to 3. Expected time 2. Is it clear? Next activity 2 to 4. Expected time is 3. 2 to 4. expected time is 3. And next one, activity 3 to 5, expected time is 4. 3 to 5 I have, means I can consider this way, 3 to 5, expected time is 4. Get that? And next one, 4 to 5. 4 to 5, expected time is 3. Is it clear? So now 4 to 6. Is it clear? 4 to 6 I will write. Expected time is 5. Is it clear? So next one is 5 to 7. So I will be drawing it 5 to 7 with a new node 7. Expected time is 5 to 7. Expected time is 5. Is it clear? So next one is 6 to 7. So I have 6 and 7. 6 to 7. My expected time is expected duration is 7 for 6 to 7. Next activity 7 to 8 I have. So I will be taking 7 to 8. Is it clear? What is 7 to 8 time duration I have here? 4. Time duration is 4. Is it clear? Now 7 to 9. That means I have another event here 9. 7 to 9 is time is an activity for me. 7 to 9 activity duration is 2. And next one, previous class, 8 to 10 is my next activity with a 6 weeks time. 8 to 10, I have 8 to 10. So that means 10 will be my new event. 8 to 10 will be with the 6 weeks of duration. And last one is 9 to 10 with the 5 weeks of duration. 9 to 10, 5 weeks of duration. This is what are things I mentioned here, time duration. This is what I calculated newly from the formula TE. So these are the values I should mention here. Now our intention is to find critical path. Once you have evaluated this, once you inserted all the times, once you draw the network, next step is to find the critical path. After finding the critical path, using the activities of critical path, we can find the expected variance of the given project here. So now, critical path CP. Path which starts from the first event, that is first node to terminal event or terminal node, that's called 10. That means my journey should start from 1 to 10 with the longest duration. You get that? Further, what are the options I have here? How to start this network? Critical path will be path. Critical path, we should try to get maximum number of duration. Maximum duration, right? If I start from 1 to 2, 2 to 3, 3 to 5, or else 5 to 7, or 7 to 9 and reach 10, that's a possibility. Or else 1 to 2, 2 to 4, 4 to 5, again 5 to 7, 7 to 8, 8 to 10, there is one more possibility. But after checking all these things, like my critical path must be the longest duration path. Now let me draw the CP directly, critical path directly. 1 to 2, is it clear? 2 to 3, okay, 4, 2 to 4 and 4 to 6 to 7, 4 to 6, 6 to 7, 7 to 8 and 8 to 10. This will be my critical path. So critical path can be written as 1 to 2, 2 to 4, 4 to 6, 6 to 7, 7 to 8, 8 to 10. This is the critical path for the given project. Now I need to find expected variation for project. Expected variance of project I need to find. How to find expected variance of the project means sum of critical events expected variances. You get that? That means 1 to 2 expected variance is what? 1 by 9. 2 to 4, look at it. Activity 2 to 4 expected variance is 1 by 9. Similarly, I need to add critical activities variances here. Now find the critical variances of each and every activity. 1 to 2 activity critical variance is 1 by 9. plus 2 to 4 2 to 4 activities expected variance is 1 by 9 and 4 to 6 activity critical activity, right? 4 to 6 activities critical activity, 4 to 6 activities expected variance is 4 by 9, so therefore plus 4 by 9. So 1 to 2 over, 2 to 4 is over, 4 to 6 over. Now 6 to 7, check it, 6 to 7 variance is 1 by 9 plus 1 by 9 plus 6 to 7 is over, 7 to 8 will come back. 7 to 8 is 4 by 9 plus next 7 to 8 is over. Next activity 8 to 10. 8 to 10 is 4 by 9. Is it clear? So these are the, now what I repeat, expected variance of a project is sum of the critical path activities here. Okay, so I need to add all the activities here. Let me add it. Since the denominator is common, so 9 will be the common denominator for me. 1 plus 1 2, 2 plus 4 6, 6 plus 1 7, 7 plus 4 11, 11 plus 4 15. That becomes 15 by 9 will be the my expected variance of the project. Maybe you can simplify that further. 5 as 5 by 3. So this is the 5 by 3 is the required. 5 by 3 is the required expected variance for this project. You can make it in a factor one, you can make it in a factor, or you can convert it to decimal point as 1.67. That's what will become 5 by 3 is equal to 1.67 also will be given solution for the problem. So this is the way we can start our PERT method for any given problem. Network